For the longest time, experts believed black holes were like giant cosmic traps. Once you get close, there's no turning back. But what if these mysterious regions of space aren't just gravitational prisons? What if they're actually gateways to other realms, hidden portals that might open into entirely new realities? When you picture a black hole, it's usually described as a bottomless well in the fabric of space and time. Light itself cannot escape once it crosses that invisible boundary known as the event horizon. Traditionally, this is where the story ends. Anything unlucky enough to pass that edge is lost forever. However, modern physics has started to suggest a much stranger possibility. Black holes might serve as cosmic bridges that connect distant parts of our universe or even lead us to entirely separate universes. This idea sounds more like science fiction than science, yet some of the brightest minds in theoretical physics are entertaining it. Their reason is simple. The known laws of nature get really weird at the edge of a black hole, and if there's anywhere in the cosmos where the impossible could happen, it might be there. To understand how black holes could operate as gateways, it helps to know a bit about their basic structure. A black hole starts as an imploded star. When a massive star can no longer produce the energy needed to support its own weight, it collapses. This collapse compresses the star's material into an incredibly tiny point, creating a region of such extreme density that it bends space and time around it. The place where its mass is concentrated is called a singularity. Surrounding the singularity is an imaginary boundary, the event horizon. Crossing it is like stepping through a door that locks behind you. Once you're inside, you can't return. All of this might sound intimidating, but it's precisely the extreme conditions around a black hole that make some scientists speculate about hidden passages. There's a related concept called a wormhole. Wormholes, if they exist, are shortcuts through space-time. Imagine folding a sheet of paper so that two distant points touch. Poking a pencil through those points would be like traveling through a wormhole, bridging a large distance in a very short time. Many researchers wonder if black holes could contain such wormholes. The math that predicts black holes in Einstein's theory of relativity doesn't automatically rule out that kind of cosmic tunnel, especially if the black hole is rapidly spinning or if exotic forms of matter stabilize the connection. From the outside, it would still look like a traditional black hole, dark, forbidding, and surrounded by swirling bands of superheated gas. But once you're inside, the laws of physics could twist in ways we're only beginning to imagine. The singularity might be more like a doorway than an endpoint. This notion leads to some mind-boggling ideas about alternate universes. It's possible that when you enter a black hole in our universe, you emerge through a kind of white hole in another universe, or another part of our own universe, so distant that it's effectively a different realm. A white hole, if it exists, would be the mirror image of a black hole. It can't be entered from the outside, and instead of pulling everything in, it can push matter out. In theory, this kind of cosmic pairing could function like an interdimensional passage. But do we have any evidence that such portals exist? For now, direct evidence remains elusive. By definition, we can't easily observe anything beyond the event horizon. Everything we know about black holes comes from what we see happening around them. The light from gas spiraling in at tremendous speeds, or the gravitational waves when two black holes collide. We did get our first ever actual image of a black hole in 2019, thanks to the Event Horizon Telescope, and more recently, an image of the black hole at the center of our own Milky Way. Still, these pictures show a shadow surrounded by light from the spinning disk of hot matter. The interior remains a complete mystery. If there's a doorway in there, we can't peek inside to confirm it. That hasn't stopped scientists from thinking about how these gateways might operate. Stephen Hawking introduced the concept of Hawking radiation, suggesting black holes slowly lose mass over very long periods as they emit tiny amounts of energy. This raises a fundamental puzzle called the information paradox. According to quantum physics, information about particles cannot be permanently destroyed. So what happens to all that information if a black hole eventually evaporates? Some theories say the information might be released slowly through Hawking radiation in a scrambled form. Others propose that the information isn't lost because the black hole is actually connected to something else, a hidden region or a different universe, meaning the data goes somewhere we can't observe. It's in that somewhere else where the gateways could reside, preserving the missing information in a realm we haven't begun to explore. Another enticing clue arises from the idea of entanglement in quantum mechanics. Particles can become entangled so that each one's behavior is dependent on the other's state, even if they're light years apart. Some physicists suggest that space-time itself might be woven from the threads of quantum entanglement. If that's true, then a black hole might tear and reweave those threads in ways that form a cosmic passage. Again, this is at the edge of what we can currently grasp, and our instruments aren't yet able to confirm it. But it fits into a broader conversation in physics about reconciling general relativity, the science of the very large, with quantum mechanics, the science of the very small. Black holes happen to be the arena where these two fields collide most dramatically. Does that mean you could theoretically fly a spaceship into a black hole and pop out in some parallel dimension? The biggest challenge might be surviving the gravitational forces. The closer you get to the singularity, the more extreme the tidal forces become. It's not a smooth ride. Objects would get stretched and compressed in what's colloquially called spaghettification. Then there's the problem of wormhole stability. Many equations suggest that wormholes, if they exist, might collapse almost instantly unless they're propped open by a kind of exotic matter that scientists haven't definitively observed. Even if a natural wormhole formed in a black hole, and even if it led somewhere else, it might flicker shut before anything made the full journey. Despite these doubts, the gateway idea persists because black holes continue to defy simple explanations. They're the cosmic laboratories where our understanding of physics reaches its breaking point. Whenever that happens, history shows that new theories often emerge to reconcile the data. As researchers probe deeper into the nature of gravity and quantum fields, we may discover that black holes aren't just cosmic vacuum cleaners, but key puzzle pieces in understanding the structure of reality itself. If they turn out to be portals, it would mean the universe has far more complexity than we ever dreamed. For anyone hearing about this concept for the first time, it might feel overwhelming. Yet it's important to remember that all big scientific breakthroughs once seemed impossible. People used to think the Earth was the center of the cosmos, or that heavier-than-air flight could never happen. In time, human ingenuity and technological advances proved these assumptions wrong. With black holes, we're at the forefront of a new frontier. High-powered telescopes, gravitational wave detectors, and advances in computational physics are bringing us closer to answers than ever before. If black holes are gateways, the implications are staggering. It might mean there is no such thing as a true dead end in the universe. Instead, one universe's black hole could be another universe's Big Bang, seeding new cosmic expansions in regions entirely unreachable from our perspective. It might also reshape how we think about time, matter, and even free will, because it hints that reality might be more like a vast network of interconnected systems rather than a single isolated realm. Exploring black holes could be the key to understanding the deepest questions about existence. Are we alone in the cosmos? Is our universe unique, or just one chapter in a larger story? We don't have all the answers yet, but part of the thrill of science is living in an era where so many discoveries still lie ahead. Each gravitational wave signal we detect, each fresh image of a black hole, and each new idea about the nature of quantum entanglement brings us one step closer to solving the mystery. If these cosmic giants do indeed open onto other realities, then black holes might be not just the end of one path, but the beginning of another. Right now, they remain some of the most enigmatic objects in the universe, a cosmic enigma that challenges our understanding of physics, space, and time. Whether they're simple one-way pits or elaborate gateways to realms beyond imagination, black holes continue to captivate scientists and the public alike. They demand we keep asking questions, keep building better instruments, and keep reaching for greater knowledge. After all, that's the essence of discovery. Venturing into the unknown and finding out that reality can be far more magnificent than anything we initially believed. Until we develop the tools and the theories to peer inside a black hole's hidden depths, we can only speculate. But in that speculation lies the possibility of expanding our conception of what the universe is and what it might become. If black holes truly are gateways, then somewhere, somehow, there might be a cosmic threshold waiting for us to cross, revealing that even in the darkest corners of space, light might exist in ways we never thought possible. If you like the content, show us some support by subscribing to our channel and like this video to make the algorithm recommend our future videos to you. Thanks for watching.